Hey everyone, here's our math problem for today. Let's say we are given this radical equation. The x root of 6 plus the x root of 9 equals the x root of 4. X is a real number. What is the value of x? You can pause the video and see if you can solve this algebra challenge. Now let's solve this problem together. Let's begin by dividing both sides of the equation by the x root of 4 so that we can make the right side be equal to 1. So the first term is divided by the x root of 4. The second term is divided by the x root of 4. The right side is divided by the same expression. Simplifying, the right side becomes 1. And then let's recall some properties of radicals. When we have the nth root of a divided by the nth root of b, this is equal to a single radical, the nth root of the quotient of a and b. And here is the common index. Based on this property, we can now simplify this first term as the x root of 6 divided by 4. The second term is also the x root of 9 divided by 4, and we just copy the right side of the equation. Then notice that 6 over 4 can be simplified as 3 halves. And notice also that 9 over 4 can be written as 3 halves squared, like this. Now the presence of this 3 over 2 and 3 over 2 here is suspicious. 3 halves is common to the two terms, except that in the second expression, there is an exponent too. To simplify this further, let's use variable substitution. Let's define a new variable, a, such that a is equal to the x root of 3 halves, which is our first term. It follows that if we square a, that is equal to the square of the x root of 3 halves, but this is just the same as the x root of the square of 3 halves. These two are equivalent. And notice that this right side here is exactly the second term. This first term here is exactly this first term here. So substituting, this is now a plus a squared equals 1. Because our a squared is this expression, which is the same as this. Then we copy the right side of the equation. This is a quadratic equation, so let's write this in the standard quadratic form. The right side is equal to 0. Using the quadratic formula, we can now solve for the value of a. Here, a is equal to -1 plus or minus the square root of 5 over 2. But notice that our a here is equal to the x root of 3 halves. This expression cannot be negative. And for our computed value of a here, we have two values. One is -1 minus square root of 5 over 2, which is clearly negative. And the other one is -1 plus square root of 5 over 2, which is positive because the square root of 5 is greater than 1. This means that we only accept that value where a is greater than 0. So a must be -1 plus square root of 5 all over 2. The other one is an extraneous root. Then let's recall that our a is equal to the x root of 3 halves. So these two quantities are equal to equal quantities. Then these two right sides must be equal. And we now have this equation. We want to solve for x. Let's write this in fractional exponent. We copy the base. The x root is equivalent to fractional exponent 1 over x, and we just copy the right side of the equation. Let's write this so that we can do away with the negative sign here. Let's write this as square root of 5 minus 1. They're just the same. So we are now solving here for x, and x is an exponent. So we can recall our logarithm. This exponent 1 over x is equal to the logarithm of square root of 5 minus 1 all over 2 to the base 3 halves. To simplify this, we need the change of base formula for logarithm. The log of a to the base b is equal to the logarithm of a over the logarithm of b. So applying that here, the right side can be written as the ratio, the logarithm of the square root of 5 minus 1 all over 2 divided by the logarithm of 3 halves. When there is no base that's written here, it's implied that our logarithm is the common logarithm to the base 10. Since we are solving for x, we do not want 1 over x, we want the x. And so we get the reciprocal of both sides of the equation. And so x is equal to the reciprocal of this, which is the logarithm of 3 halves over the numerator, the logarithm of square root of 5 minus 1 all over 2. Again, using this change of base formula for logarithm, we can now write this value as 1 logarithm, the logarithm of 3 halves to the base square root of 5 minus 1 over 2. This is now our final answer and its equivalent decimal approximation is approximately negative 0.84259, which is now our answer to this given algebra challenge. And so we are done.